Hello friends, this is the third video of the series of lectures on limit of a function. In this video I will try to solve few important problems using sequential criteria. First of all, for the first problem let us consider a function fx which takes the value 1 for rational x and which takes the value 0 for irrational x. Then we have to compute limit extends to a fx where a is any real number. Then we will try to use sequential criteria. So let us consider two sequences. First of all, xn is a sequence of rationals converging to A and yn sequence of irrationals converging to A. Note one thing, xn not equals to A for all n and yn not equals to A for all n. So clearly by the definition of fx, f of xn must be 1 because xn is a sequence of rational, and f of yn must be 0 because yn is a sequence of irrational. So clearly their limits are different. So limit f of xn is 1 and limit f of yn equals to 0. So we have chosen two different sequences, both converge to A, but their limits are different. So in this case sequential criteria is not satisfied. So such limit does not exist. Now come to the second problem. Limit extends to 0, 1 by x square equals to infinity. We have to prove this. So limit is not a finite number, so that we have to show that for given positive number m there exists some delta such that 1 by x square is greater than m whenever mod x is less than delta. So now if 1 by x square is greater than m, that means x square is less than 1 by m, which implies that x lies between minus 1 by root m and plus 1 by root m. So this implies that mod x is less than 1 by root m. So minus 1 by root m and plus 1 by root m are two bounds. So if we choose delta as 1 by root m, then we get mod x is less than delta, that is 1 by root m. So easily our result will be proved. So this is epsilon delta analytical approach to solve this type of problem. Now this is the third problem. In this problem we have to show that limit extends to 0 signum x does not exist. So first of all we have to know the definition of signum x. What is signum x? The graph of signum x has been shown in the right side, and the definition of signum x takes the value 1 for positive x, takes value 0 for the point x equals to 0, and takes the value minus 1 for negative x. So we have to show limit does not exist. That means we have to use sequential criteria and we have to choose two different sequences. So let us consider xn equals to 1 by n, where n is natural number, and yn equals to minus 1 by n. Then clearly xn consists of all positive numbers, so that f of xn will be 1 by the definition and f of yn will be minus 1 because yn consists of all negative terms. So limit f of xn will be 1 and limit f of yn will be minus 1. Note one thing, xn converts to 0 as n tends to infinity, and yn also converts to 0 as n tends to infinity. That means two basic sequence converge to the same point, but their limits are different. So in this case also sequential criteria is not satisfied, so that such limit does not exist. Now fourth problem says that we have to show limit extends to 0, box x does not exist. Box x is nothing but the greatest integer function. In this case limit x approaching to 0, so we can easily solve this problem only considering any neighborhood of 0 and 1. So box x takes the value minus 1 when minus 1 less than x less than 0, and takes value 0 when 0 less or equals to x less than 1. that is the definition of greatest integer function. So we have to consider two different sequences. Suppose xn equals to 1 by n plus 1 and yn equals to minus 1 by n plus 1. So easily, same as previous, xn converts to 0 as n tends to infinity and yn converts to 0 as n tends to infinity. But f of xn, the sequence f of xn, consists of all zeros, because in this case, according to the definition of box x, the value will be 0 for positive x. So sequence fxn consists of all zeros, which implies that the sequence fxn converts to 0, and similarly the sequence f of yn consists of all minus 1, so that the sequence f of yn converges to minus 1. So we have chosen two different sequences, both converts to 0 as n tends to infinity, but their functional sequence converts to different limit. First one converges to 0 and second one converges to minus 1. So since their limits are different, so that such limit does not exist. So that means limit extends to 0, box x does not exist. This is the fifth problem in which limit does not exist. So we have got the idea that to show non-existing limit, we can easily use sequential criteria. That means we can choose two different sequences whose limits are different. So in this case, the function is very nice function, sine 1 by x. So we know the graph of sine x. So sine 1 by x is quite different from sine x. The graph has been plotted here. So let us choose the function fx equals to sine 1 by x. We know that sine t will be 0 when t equals to n pi, where n is any integer. And similarly, sine t equals to 1 implies that t is pi by 2 plus 2n pi. So in this case, we have to consider two nice sequence. So first of all, xn is a sequence of the form 1 by n pi and yn is the sequence of the form 1 by pi by 2 plus 2n pi. So easily limit xn is 0 as n tends to infinity, and the limit yn is also 0 as n tends to infinity. But xn equals to 1 by n pi, so clearly f of xn equals to sine n pi, that means 0. And similarly, f of yn equals to sine pi by 2 plus 2n pi, that means 1. So we have got limit xn equals to 0 and limit yn equals to 0 as n tends to infinity. But limit of f of xn goes to 0 and limit f of yn goes to 1. So these two functional limits are different. First one is 0 and second one is 1. So they are different. So in this case also sequential criteria is not satisfied. Hence limit extends to 0, sine 1 by x does not exist. So these are very useful problems using sequential criteria, and in very next few videos I will try to upload the idea of one-sided limits at infinity, and few basic properties, squeeze theorem, and few standard limits. So thanks a lot.